Hello, Mr. Anishe.
Hello, sir. Good morning. Good afternoon, sir.
Good morning. Yeah, just want to confirm if the audio is good.
It's okay. Can you hear me very well?
Yes. Hi, everyone. Thank you for joining us. We'll be starting in a few minutes. Thank you for joining us. Please kindly invite your friends and colleagues who should also be here for them to benefit from the class. Invite them now and send a message to them on WhatsApp. Thank you very much.
Hello, sir. Can you hear me?
Yes.
Please. I'm planning to use my system, so I want to know if I can share from my system here.
Yeah, sure. You can use any device. You should be able to share.
Can you see my screen? Please, can you see my screen?
Yes.
Yeah, but why is your voice echoing?
Yes, we can. I'm not sure. I think you gel with two accounts, Mr. Nishi. Your voice is bringing echo. Maybe you have to leave.
Yes, I will turn one off now.
Okay, cool.
What about now? I think it's okay like this.
Yes, yeah. Perfect.
So I just want to use it because I don't have much. Okay, thank you very much.
Yeah, I think we can start now. It's almost 10 minutes after 10. Hello, everyone. Thank you for joining us again this week for another session on Learning is Fun, which is dedicated to preparing you for JAMB UTME exams. And afterwards, we also look at WAEC after the JAMB exams. So today we'll be looking at chemistry, and we already have our instructors around, the person with Mr. Anish Emmanuel. So before we jump into the class, this is just a reminder for our students and for the attendees for this section that you can prepare better on your own and making use of South Africa Learning app to guide you on your learning journey. Our instructor have already simplified all what you need to learn from SS1 to SS3. These are major curriculum you need to know in order to ace your JAMB UTME exams. But fortunately, we are only able to cater for students who understand or can speak Yoruba for now. So if you're a Yoruba speaking student, kindly go to our app, go and learn on it for free. See the free courses and see if it's something you love, and you can proceed to unlock other content or other courses on the app. So go to app.sciafrica.com. and create an account with just your phone number, and that's all what you need. Then you're ready to go. So without any further ado, I would hand over the mic to Mr. Anish Emmanuel to proceed with his class. Thank you very much.
Thank you very much, everyone, and thank you very much, the CEO, for this privilege. I never take it for granted, and I want to appreciate all our students, our learners, those that have joined and those that are yet to join, and those that are planning or they are trying to join, but I think the network has not been allowing them to at least come on board. So I want to appreciate everyone for the time which you have tried to devote to at least get a very solid and good information. And I pray you shall all succeed by the special grace of God in Jesus' name. So that is that. Today we are looking at chemistry, and I wouldn't want to waste much of our time. We have a limited time at all. As the CEO has rightly mentioned my name, Hanish Emmanuel Kennedy, the chemistry tutor for South Africa. And thank God he has tried introducing the app to you also. It is a very good thing for you to at least go and check. Look at that. Today we are going to be looking at chemistry, but there are some things I want us to look at. If you have your writing material with you, in fact, you need to have, I shouldn't say if you have, you must have your writing material with you. Just bring them close, and your calculators, you're going to be using it. So if you have just take your writing material, your Bible, your pencil, your calculators, and the materials you'll be needing for this class. Firstly, before we go into the main thing of today, I will want to quickly tell us some hints. We need some hints that are needed for us to succeed in UTME, most especially chemistry. A lot of people from foundings research will discover a lot of people complain about chemistry as a subject that is a little bit challenging, somewhat volatile in one way or the other. So I'll try to come up with like 15 success tips that will help us in getting a good grade and getting good mark in chemistry. And once you're able to get your marks in chemistry, I'm telling you, which happens to be one of the most challenging in subject in mathematics, I mean in UTME or in all courses or science, you discover that you are you're on top. That is it. Let me use that. So today, what are the hints you need to take notes? There are some things you need to understand about UTME or JAMB, especially coming to chemistry. Number one thing is the first hint is you understand the exam pattern. I have like 15 points here. The first one is understanding the exam pattern. If you are able to understand the exam pattern of UTME, I am telling you, you are the top. I'm confirming that to you. You are the top. That is one thing. I want you to know it is not how far, but how well. The little we are able to cover up today will give you what is needed. I am telling you. And that is why we don't read hard, but we read smart. Don't just say you are practicing and you are not practicing being smart. You need to be smart when it comes to exams in UTME. Now, the second one is you set a realistic goals. Setting a realistic goals. Now, let's say today you might just wake up and say, okay, I want to cover this particular topic. Something you know you can achieve. Don't just set something. Don't just say you want to do this. You understand? Set something you know you can cover. Okay, I want to cover factorization today. I want to cover separating techniques today. Are you getting it? I want to cover tutorials. I want to cover a particular separating technique today. Then it should be realistic, something you can achieve. Number 3 is use past question, and that is what we are trying to use today now. We're trying to look at past questions, and that will be able to give you some pathways, some hints in passing or in getting good grade. You want to have 360, you want to have 300 over 3 or above 300, 270 above, then you have to practice past question. It will be able to guide you. The number 4 is your practice time management. Practice time management. I normally tell my students, most especially in tutorial classes like this, I do tell them that when you go for any examination, most especially science, or let's say chemistry, let me focus on chemistry now. We have calculation aspect, you have to do some theoretical aspect there. Don't waste your time in the theoretical aspect. I mean, in the practical aspect. The first thing, go to the theoretical aspect, ensure you read and understand, that you'll be able to at least speak. So the time we are going to be wasting, are you getting it? Just wasting time on calculation aspect, and you're unable to at least finish it. It will affect a lot. So when you try solving, I do tell them, if it is calculation aspect, just try to manage your time. Look at it. Within 60 seconds, I should be able to do this. Within this, if I know it's going to consume a lot of my time, let me go to the theoretical part. Like this, what is the principle of this? What is that and that? I get it now. Look at the question number 1. You should know, look at this question number 1 says, which question paper type of chemistry is given to you? Now we are dealing with question type B. And you might not even focus on this. Then you'll be wasting time on this. These are what you need to at least try to practice your time management. Another thing, which is number 5, is practice regularly. Most especially chemistry. Practice regularly. If you're not practicing regularly, it's going to affect your result, the outcome. It's going to affect your outcome. So when you practice, now I do tell my students, I said, chemistry, you can compare chemistry with other subjects. Chemistry is quite different from other subjects. It's a volatile, you understand. When you understand that, okay, you give priority to some subjects. When you're able to give priority to some subjects, it's going to help you. You're going to have a good result. The outcome, you will even smile when you see the outcome. But when you're not practicing, it's going to affect. You just practice on Monday, on Tuesday, nowhere to be found. On Wednesday, nothing. Thursday, nothing. Then on Friday, you now bring out your chemistry note again. No, it doesn't work like that. Another point is you create a study schedule. How many of us have a study schedule? Imagine what we have SS3 student that does not have a study schedule. Till now, when you practice, you write waiting for WAEC or JAMB. It's going to affect. It's going to affect. If you have not been practicing, you still have time. I did tell my student, I said it is not over until it is over. You still have time. Things can still be done. If you believe in yourself, things can still be done. So you need to create a study schedule. You need to create a study schedule. Then also you engage in active learning. Engage in active learning. Don't just learn. Don't just say you want to do this. Active. Let your learning be active. Another point is you join study group. This is a particular study group. No one is an island of knowledge. We are all learning. And that is why one of our words says we learn every day. The more we live, the more we learn. Join a study group. Join groups that will help you to motivate, to even enlighten you more. Don't just join groups that you just discuss about this. I try making some findings about research over most of our students. The issue they have in school now is they spend much time on WhatsApp, on social media, than learning. If you are joining a group that will be motivating or be encouraging you, giving you a lot of ideas, good ideas about your study, it's still okay. It's still okay. So you join a study group, a group in which when you join, they can at least educate you. You can also learn from them and they learn from you. From that, because we have different calibers of people, when they teach, they understand better. When they teach, they understand better. If you're kind of person and you are trying to study yourself, then it's going to help you in this way. It's going to help you. Another one is use educational app. And thank God for South Africa. South Africa is one of the best educational app we have in town now, which you can join. You use educational app. When you go to SS1, you see different of our topics there that has been expatiated. We've tried elaborating, discussing it in details in Yoruba language. We are still coming with other languages. I get it. But we started from Yoruba that can help you understand. I tell my students, most of our learners, they find it difficult because they can't try to understand or interpret. But when you're able to interpret to your mother language, indigenous language, you get a higher chances, a lot of benefits to understand better in depth. So you use educational app. South Africa is there for you. Thank God for South Africa. Use educational app. Utilize it. Subscribe. This is your time. It's an opportunity. Who knows? Maybe this is because of you hearing me or listening to me now, and why South Africa has come to exist. So you need to use educational app. Another one is stay healthy. There's not how you can be learning and you're having headache. It is not done. Stay healthy. Then you take break. All work without play make Jack the double. And now take note. When you're talking, if you have tried studying yourself, if you have studied yourself very well, then when you try studying for like 25 minutes, take a break of 5. Not when you're taking a break, it's not that you want to go and play football. No. At least relax your brain and try to learn. That is what I'm trying to say here. Another one is engage in mindful revision. When you read, take note, you jot something down. Try to revise. Maybe during that break, you can just walk up, take a walk, and just revise. What have I learned? What is this? If they ask me what is wave, if they ask me what is rate of chemical reaction, what are the factors affecting rate of chemical reaction? These are the things you've just finished reading or you might have gone through. And that one is self-assessment. Assess yourself. Assess yourself. Have I been able to achieve this? You have set a target, a goal, an objective. Now try assessing yourself. Then you stay informed. Stay informed. JAMB might decide to change their dates so that you will not be preparing for a date that has been postponed. Then you not get there, you not be disturbed. Most people just feel before writing the exam because of what they've changed the settings. Now, initially, let's say for some years back, JAMB questions happens to be like 50, 60 questions, objective. But now it's now 40. So if you are preparing for 50, you're on your own. So you stay informed. And the next one, the last but not the least, is believe in yourself. Anyone that believes that he can do it, then you will go far. Believe in yourself. Believe in yourself. So that is that. Now we are looking at this. Let's look at question 1. Which question paper types of chemistry is given to you? Most of you might be given type B, type C, or any type. So you know this is type B. And now number 2 says, what is the concentration of a solution containing 2 grams of sodium hydroxide in 100 centimeter cube? In 100 centimeter cube. So this is, you are asked to calculate the concentration. So in order to convert this one to concentration, which is going to be a mole per dm cube, we just write, let me use my pen here. Coming or tools. I think I can use my tools here. Then if I cannot, I will have to switch to my tab. So if you are using this, what we are going to be doing here is 2 grams. We've gotten our 2 grams. So in this, you just convert this one into 2 grams of sodium in 100 centimeter cube. So when you do this, when you calculate this, it's gonna give you 2 over. I believe most of us have calculators with us here. You can just press your calculator and just divide with this. 2 divided by 100. 2 divided by 100 will give us this times 1000. So sodium hydroxide is 40. Find the molar mass of sodium hydroxide first. So when you find the only thing here, concentration, just find the molar mass of sodium hydroxide. Then you see the gram divided by molar mass. Then you will get your mole per dm cube. Your mole per dm cube. So 2 divided by 40. In 40, you will have your answer. You have your answer, which is answer B, 0.5. Good. Now let's look at number 3. Which of the following property is not peculiar to matter. Now, when you are answering this kind of questions, you will not be expected to use more time compared to the time we use in number 2. So in solving this kind of question now, which of the following is not it is not peculiar to matter? Now, what A says, kinetic energy of particle increases from solid to gas. B, random motion of particle increases from liquid to gas. And C says, orderliness of particle increase from gas to liquid. And the random motion of particles increases from gas to solid. Now, when you look at this, one thing about UTME is this: 2 answers will be out of it, while 2 answers will be close. But one is correct, the right answer. The right answer. So the answer here is just D, without wasting time. It's just random motion of particle increases from gas to solid. Are we getting it? So it cannot increase from solid to gas at all. Random of particles. When we are talking about random motion in our physics, it will help us a lot here. Number 4, the principle of column chromatography. Now, this is if you have not been able to study chromatography very well, you might not be able to answer this. Now, in answering this, talking about chromatography, one thing that I normally tell my students, there are some hints, because when you go for competitions, there are some things you just have to have in mind. The chromatography, one thing about chromatography is we use in separating anything that have to do with what? Colors. It's mainly used for color separation. You're having different colors, like the paper chromatography. We have different type of chromatography. We have the color, we have the paper, we have the thin layer chromatography. Are we together? So with that, now another thing we need to know in this to answer a lot of UTME questions: bring related ideas. Are you getting it? Bring related idea, and that's what we're doing number 4 now. So with this now looking at that, I have 2 phases in in chromatography. I have the moving phase and I have the stationary phase. So looking at that again. So let's quickly look at the option. Move at different speed in the column. Again, the principle of column chromatography is based on the ability. Now, dissolve in each other in the column, react with the solvent in the column, and react with each other in the column. So when you look at this, very simple, very simple. So this is very simple here. So in order to do this, it is just what the answer is: move at different speed in the chromatography. When you're trying to separate ink now, it will help very well. It helps very, very well when you're trying to separate ink. And that was why I tried mentioning stationary phase and moving phase. The stationary phase and the moving phase here. So number 5, that's number 4 is A. Number 5, a lot of people will miss this number 5. A lot of people will miss number 5. And that was why I said one of our hints in success is when you practice regularly. You might have gone through a particular topic and you will just have, let me just leave it. Now, for this time, let's say let's look at WAEC. If you try looking at WAEC for like 3-5 years consecutively, you discover that, or respectively, you discover that there are some questions or there are some topics WAEC cannot but bring out question from. There's no how. There's no how. They will surely bring something out from it. WAEC will surely bring something out. So when you try separating, you understanding, it is not how you read. Wow. No. Some people will finish all the textbook. They will read a particular part and on getting to the exam hall, whereas someone just try or manage to read like only, let's say maybe 5 or 6 chapters. And on getting to the exam now, the 6 question that will be coming in the theoretical part in WAEC is just the 6 on the 6th topic, the last person has tried going through. But someone that have been able to read, or you've read from pali to pali, a lot of people say, yes, I want to read from pali to pali, and the person might not be able to understand. Answer the question very well. So when you understand and you practice regularly, it's gonna help. So here, this question is not the first type. They've been repeating this question like this. This question, they have been repeating question of such like this. So they now say, which of the following an ideal gas? An ideal gas. The ideal gas here, without wasting of our time, is this N. When you see this question, just go. You don't need to waste your time. This is N. This is like a bonus. N is the ideal gas. It is not M, it is not K, it is not L. It is N. It is N, straightforward. So when you go to the ideal gas equation, you see the ideal gas talking about different gas law. Yeah, when you get to gas law, you see a graph of such. So number six, which of the following question is correct about periodic table? Which of the following question is correct about periodic table? Now, when you look at it, A, the non-metallic property of the element tends to decrease across the period. Non-metallic, it tends to decrease. Is a lie. It is not possible. Whereby when we're talking about across the period, that is from left to right, is not. Don't forget that group 1 element are metals, group 2 metals. So why will non-metal now start decreasing? No. So when they say it is increasing from left to right now, then I can still say yes. Because from right to left, it will decrease, then it will increase down, back. So we can still go with that. So, but this one, the answer here, okay, let's continue. This is the valence electron. That the valence electron here, the valence electrons of the element increase progressive across the period. Valence electron. Don't forget that valence electron will help us to know the group an element belongs to. Now, again, let's quickly bring idea. What is valency? Valency is the ability of an element to combine with another. That is valency. Now, but when we say the combining power of an element, yes, that is valency. But valence electron is the outermost electron an element possesses. The outermost electron an element possesses. So the element, the electron you can find in the outermost shell is valence electron here. Are we together? So when you understand this, now number 3, elements in the same group have the same number of electrons. Elements in the same group have the same number of electrons. Is electron shell? No. Elements in elements in the same period have the same number of valence electrons. No. So the answer is B. The valence electron of the element increases progressively, which means when you are in group 1, you discover that the valence electron there is 1. When you go to group 2, the valence electron there is what? 2. When you go to group 3, the valence electron is what? 3, 4, and so on and so forth. That is the way it works. Number 7. The relative atomic mass of a natural occurring lithium consisting of 90% lithium and 10% lithium is this. This is very easy. In answering this, if you go back to your SS1, when we were trying solving isotopes, or I think yes, is in scientific application also, when we are solving isotopes, molar mass, mass number. So in solving this, just write your 60. You can see that when you try looking at the percentage here, everything is 100. So it can even there are different ways you can use in solving this. So when you solve this, where is it? We have 6.9, 7.1, 6.2, and what? And 6.8. So we just try making, it's like when we are trying calculating that of chlorine. I think I can use my biro here, but unfortunately I can't use my biro here. Maybe I'll just say 1 or 2 things about that. Then when we our own leisure time, we can try calculating that. We just try calculating that here. And this question is a UTME question, also is found in most of our topics. And what they call it when we are dealing with, I quickly want to, yes, the atomic mass. When we are dealing with atomic mass, there are questions we can see there that will help us. Let me try bringing my by. I'm thinking of how I want us to calculate it together. So the answer here with my calculation here is 6.2, which is going to be C. 6.2, which is going to be C here. 6.2. So number 8. Number 8 is an isotope has an atomic number of 15. An isotope has an atomic number of 15 and a mass number of 31. A mass number of 31. So the number of proton is, it contains is what? The number of proton it contains. The number of proton it contains is dash. Now, this is an isotope, but we're just talking about isotope. You can see, look at that question now. That was what I was saying. You need to what? Understand the exam pattern. In what way did they set question? So when you're able to follow that, I'm telling you, you will stand out. Look at isotopes here, and I'm still trying to refer to isotope in number 7. Look at that. Look at that. Most of the questions they normally give, this number 7, most of the questions they normally bring here is let's say chlorine has 35 and the other one has 75 or something like that. Okay, 75, 25. That's the mass number. They will now ask you to calculate. Are you getting it? The molar mass or the relative molecular mass. Now, in number 8 now, an isotope has an atomic number of 15 and a mass number of 31. The number of proton it contains that. So this thing is very simple. Proton number is also the atomic number. Proton number is equal to the atomic number and is equal to number of electron, except if it is carrying a charge. Except if it is carrying a charge. If the element is carrying a charge, okay, it's going to be different. If it is not carrying a charge, no. Are we together? It is no. But when it is carrying a charge, that is something very simple here. Now, looking at the answers here, we have A 16, B 15, C 46, and D 31. So from what I've just explained, mass number is equal to atomic number plus plus number of neutron. But mass number, as I said, mass number is the number of atomic number plus neutron number. Here now, atomic number is number of proton and is also number of electrons. So when we know our atomic number 15, then our number of proton will be 15. The molecular lattice of iodine is held together by dash. Is held together by dash. Very, very simple here. Very, very simple here. This number 9. Iodine crystals. Iodine. It is a very weak. It's like when we're talking about different. Okay, let's quickly talk on this. Number one thing is when we're talking about ionic bonding. Ionic bonding is talking about transfer of electron from metals to non-metal. Yeah. Now, when talking about covalent, we're talking about sharing between non-metals. But when we're talking about coordinates, which is also dative, it also has to do with sharing. There was a question like that they were asking the distinguish between covalent. Covalent and coordinate covalent. So it's sharing. But one thing that differentiates the two is instead of the two contributing the electron that is going to be shared, but dative will not be doing that. It's going to what? Because it has a lone pair of electron. So it's going to give out. It's going to give out the shared that the two of them were supposed to use. So it's going to give out. So metallic is talking about metal. Hydrogen is a very weak van der Waals. But van der Waals here is the answer because the molecular lattice of iodine here. The molecular lattice of iodine is what? Is van der Waals force. Van der Waals is a very weak, very weak. Number 10. The arrangement of particles in crystal lattice can be studied using arrangement. This is very simple. You need not to waste time here. It's just S3. You cannot go to alpha ray, beta ray, and gamma ray here. No, it's S3. It's S3. Arrangement of particles in crystal lattice is what? S3. Now look at this. The time using, we use here is not even much. The reason why I can say this is the answer, because I have practiced continuously. You can see I said practice regularly. People that have studied this will not even waste time in answering questions like this. People that have studied past questions here will not be wasting time. Number 11. Number 11. From the diagram above, find the amount of solute deposited when 200 centimeter cube of the solution is cooled. From the diagram above, find the amount of solute deposited when 200 centimeter cube of the solution is cooled. Now, let's look at this first. We have the number of moles here of solute and we have temperature. Find the amount of solute deposited. The amount of solute deposited, we have A 0.1 moles, 0.2 moles, 0.01 moles, 0.02 moles. Now we can take our calculators here. You can take a calculator here. Let's try checking this. Okay, we have from the cool from 55 degree to 40. Where's 55 to 40 here? 55 degree to 40. So 10, 15. We have like 15 here. You have 15. Okay, 55 minus 40. Okay, 15. We have 15. From 15, you can now say, okay, 200 in this. 200 divided by 200 divided by 200 divided by 10. We have divided by 1,000. 1,000. So 200 divided by 1,000. Yeah. We should have 0.2. Okay. Now the answer is 200 divided by 1,000 because of this. It's like this question is on solubility. It's deposited here. So the answer is 0.20 moles. 0.20 moles. So number 12, we're looking at the time. The importance of sodium aluminate 3 in the treatment of water is dash. I don't need to waste time like the time I've wasted in number 11. So if I have a question like this in UTME, what I will just do is I try going to the calculation aspect. Let me do the calculation aspect first. Then the theoretical part I will know. Then I will just take my time. Now, the importance of sodium aluminate 3 in the treatment of water is now. When you look at sodium, aluminum, it's aluminum, sorry, alum. Yes, I'm going to alum. When you look at alum, what is alum used for? What is alum used for? Alum is quite different from chlorine. A lot of people too, they do misunderstand or they misconceive the two works for each other. They take the two jobs for each other. The work of chlorine is different from work of aluminium. I mean alum here. So but I'm using sodium aluminate here, taking it to alum here. So the work here is to coagulate. And that is why when you throw alum into water, what will it do? It's gonna coagulate. It won't kill. Alum, I tell people, alum does not kill. Alum will just make every of the sediment or particles to settle down, and they will become sediment at the baseline or the bottom of your water container. But for chlorine, chlorine will kill the germs. These are the two things about them. Chlorine will do what? It will kill the germs. Chlorine will kill the germs here. It's not that alum will coagulate, and you can see causes coagulation. It's not neutralizing acidity. It's not going to prevent the goiter and tooth decay. No, you're preventing the water here. So it's going to what? It's going to coagulate. Number 13. Number 13. What types of bond exist between an element X with atomic number 12? Which element is number 12? That is aluminium. And Y with atomic number 17. So it's aluminium chloride. Aluminium chloride. Are we together? Aluminium chloride. So when you look at aluminium is a metal. Chlorine is a non-metal. From that, it should be giving you or sounding a particular what do you call it? Message to you, send a signal to you that when you are dealing with metals and non-metals, And that is when you look at the valence electron, 3 to 7. Because aluminium. Oh, magnesium chloride. Magnesium is number 12. Aluminum is number 13. I'm really sorry for that. So magnesium is number 12. Aluminium is number 13. So chlorine is number 17. So we are dealing with atomic number 12, which is the compound now is magnesium chloride. So meaning 2 to 7. So meaning metals to non-metals. One will be donating, one will be accepting. Transfer of electrons. So what will be? Without checking the answer, you know that the answer is going to be ionic. It's going to be ionic or electrovalent. There's no ionic here, but it's electrovalent. So the answer is electrovalent. So when you say ionic and electrovalent, they are the same thing. Oh. Aha. So number 14. Oh, hardness of water. Hardness of water. What do you understand by the word hardness first? When water does not readily form ladder with soap, is what we call hardness. Gone are those days before I have in depth or I have a little idea about chemistry. When they say hardness, I will be looking at it. The water we have been drinking is all this. Why? Why is Oyinbo bringing all these things? Why are these Oyinbo? You can see why South Africa is good. When we say hardness of water, show me Emma Leni Kolele. Omi ta for work on. Tí mo lè fọwọ́ gbá mo lè ṣe òun ló le. Àbí àwọn olóyìnbó tún dé wọ́n sọ pé omi tuntun le. Níbo lomi tin le? Ká má rí. So with that, when you look at that, hardness of water is mainly due to the presence of that. Two things we call hardness of water. Two ions present in water we call hardness. Now we have calcium 2+ and magnesium 2+. If these are present, it's going to cause hardness of water. Now let's look at A. Calcium hydroxide or calcium or magnesium hydroxide. No. So the only thing, another thing we need to know is calcium and magnesium of trioxocarbonate or tetraosulfaces. Hydrogen trioxocarbonate or tetraosulfaces. Those are the two. That is calcium and magnesium of calcium. Tetraosulfaces and trioxocarbonate. So the two will cause hardness. But when we are dealing with what do you call it? Hydroxide. No. Hydroxide will never. So B, calcium trioxocarbonate 4 and calcium tetraosulfaces. Good. Sodium hydroxide, no. Anything hydroxide, no. Sodium and chloride, no. The answer is B. Tetraosulfaces and trioxocarbonate. I said it earlier. That is B. Number 15. 15 says a suitable solvent for iodine and naphthalene. A suitable solvent for iodine and naphthalene is what? A suitable solvent. Now, what is the universal solvent? I believe every one of us will know universal solvent, which is water. What is solvent? Solvent is what we use to dissolve what? Solute. Simple. We know that one. Glory be to God. That is number one thing. Now, once you understand this, that when we're talking about all we have, water is a solvent, ethanol is a solvent, benzene is a solvent. So which one will now be useful in dissolving iodine and what? And naphthalene. The answer is not water. The answer is not water. It's not water and it's not benzene. The answer is ethanol. The answer is ethanol here. The answer is ethanol. If you use water in dissolving iodine, you just see that as time goes on, even if you are using hot water, it will vaporize. If you have seen iodine crystal, it vaporizes. So are we now going to use water? No. The answer is ethanol. Is ethanol. Number 16. Which of the following noble gases is commonly found in the atmosphere? Oh, very simple. When we are dealing with air, you know, air has a mixture of different things. We have oxygen, we have neon, we have argon, we have nitrogen, we have hydrogen, we have a lot, and we have even particulate nature. We have particulate nature of matter there. We have particles and so on and so forth. But when we are talking about the noble gases, don't forget that the noble gases are group 8 elements. They are the group what? The group 8 elements. So which of the following noble gases is commonly found in atmosphere? In atmosphere. So the answer is helium. Is helium. Helium is mostly found in the atmosphere. Helium is mostly found, is the noble gas. Now look at this now. Argon is a noble gas, helium is a noble gas, neon is a noble gas, xenon is a noble gas. But the one that is commonly found in the atmosphere. Now look at what JAMB is doing now. If you have the mindset that, okay, 2 will be correct, 2 will not be correct, okay, you will see that all these, they are what? They are group 8 elements. And I said, noble gases are found in what? In group 8 elements. So the one that is mostly commonly found in the atmosphere, commonly, not that others are not, but commonly is what? Helium. Helium. If you have tried listening to our app very well, the South Africa app, where I tried discussing about air and flame, I said something about this. Air and flame. So I'm advising you, go to our app, download it, listen to it. It is very, 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 very important. It's something you might just lie down and listen. You will just see that the thing is just entering into your brain. Entering. So that is that. Number 17. Number 17. Oh, we've done rate of chemical reaction. Go to our app also. All these things have been discussed. What's the share this number 17? Has been discussed in our app. When I was talking about rate of chemical reaction and the chemical equilibrium. Rate of chemical reaction and chemical equilibrium, I've discussed. And I said something about this positive. This is going to be an endothermic reaction. So in the above reaction, or in the reaction above, an increase in temperature will what? When I increase the temperature, look at it. One thing we need to understand. If I increase the temperature here, you can see this is gas. This is gas. I want to understand this. And this reversible reaction. So when I increase, the only thing that will happen here is there's going to be increase. If you increase the value of the equilibrium constant, that is what it will do. I've not checked. I don't need to check everything here. So when you understand, you are very sure. It's like when they ask you 2 times 2, and they are putting 22. But because you are sure, you just go, this is the answer. And that's what we are doing now. This is like revision to me. If you have listened to our app very well, you know these are just revision questions. They are good revision questions. So it will increase the value of equilibrium constant. It will never decrease value. What did it call of equilibrium? Increase the reactant production. No. Shift equilibrium to the left. No. If I increase temperature here, and even it will shift it forward now. Look at that. So that is that. It will increase the value of what? Of the equilibrium constant. And I believe we can write the equilibrium constant for this kind of reaction. The product will be at the top, the reactant will be at the bottom. So number 18 now. Number 18. Oh, this is acid base and salt. This is ethanoic acid reacting with OH. Okay, ethanoic acid plus hydroxide to give is a reversible reaction. At this it dissociates ethanoic. It dissociates. Now, this CH3COOH, let me bring another question here. When they are asking you a very simple question here, that what is the basicity of an acid here in CH3COOH? Very simple. The basicity of an acid here is when this one dissociates, you can see we have CH3COO minus, and it's going to give us H plus. So the basicity of an acid here is only 1. It is not 4 because I said basicity of an acid is the number of replaceable hydrogen ion. No. Yes, it is right, but it depends on when you are able to dissociate. When they dissociate, a lot of people misinterpret the definitions. You understand? So in the reaction above, which is this, CH3CO minus aqueous is what? Let me explain. We will answer this question together. It's very simple. It's a conjugate here. So base and acid is out of it. Conjugate acid or conjugate base. But for us to know, maybe it is conjugate acid or conjugate base now. Now we have to dissociate. Let's say CH3COOH. When they dissociate, what will it give us? It will give us CH3COOH minus and what? H plus. Meaning H plus is the acid, while CHCOOH is the basic, the conjugate base here. So the answer is what? Conjugate base. And even they were asking, let's say H plus now, it's going to be the conjugate acid. But this one is here. Very, very sure it's conjugate base. How many cations will be produced from a solution of how many cations? This is very simple. How many cations? Will be produced from a solution of potassium aluminum tetraoxosulfate 6. Potassium aluminum tetraoxosulfate 6. Oh, this is an alum. KAL. So don't forget, and this is a double salt. a double salt. Mind you, alum is a double salt too. It's not a basic salt. Please take note. Alum is a double salt, whereby when it dissociates, we are having 2 cations and 1 anion. I've answered the question. I've answered the question already now. So when you look at it, how many cations will be produced in the solution? So far, you are able to understand. See, all these things have been what? Explained. It has been explained. When I was talking about, what do we call it? Acid, base, and salt. When I was talking about acid, base, and salt, I discussed about these things, about type of salt. We have acidic salt, we have basic salt, we have double salt, we have complex salt. Again, normal salt, acidic salt, basic salt, double salt, and complex salt. I said something about normal salt. I said in normal salt, all the replaceable hydrogen ions are being replaced by metal. They are being replaced by metal. But when we come to acid salt, they are partially replaced. So, and that is the reason when you see in a normal salt, you will never see element of H. When you go to acidic salt, you will see H. It's either 1H or 2H. But when you go to the basic salt, you are going to see OH. But when you come to double salt, the only thing for you to be able to identify double salt, very easy, without wasting time, is going to give you 2 cations and 1 anion. That is it. And when you are talking about complex salt, it's talking about a ligand that is in between, and a lot of is like drawing the attention of people of other words, radicals. So the answer is 2 here. Which of the following is not an alkali? Look at this. It's not an alkali. Now, when you look at everything, they are like base. They are base. When you look at that. Now, how do we differentiate this? How do we identify this? Yeah, I know it. Because what is a base? A base with what? When you dissociate it in water or neutralize it in water, is going to form what? OH minus as the only what? Negative. I get it. Negative ions. Now, alkali. I think I was telling someone yesterday online also. I said alkali is different from base. All alkali are base. Not all base are alkali. Base, when you dissolve them in water, it will form. There is going to be base that is going to dissolve. Another base will not dissolve. The soluble base will. The soluble base are called the water alkali. So only the soluble base here. We have sodium hydroxide is a soluble base and is an alkali. Calcium hydroxide is a soluble base, it's an alkali. Magnesium hydroxide is a soluble base and is an alkali. All hydroxide. Now the only thing here is what? Although it is a base, ammonia is a base, but it is not an alkali. So it is what? NH3. That is the answer. That is it. 21. An effect of thermal pollution of water body is that thermal pollution of water body. Thermal, that is it. Thermal is it. Thermal pollution of water body is that the volume of water reduced. B, volume of chemical waste increase. C, level of oxide of nitrogen increase. Level of oxygen reduce. Now, when you eat water, what makes the living or the aquatic animals in water die easily is because of the what? Reduction in the level of oxygen in water. And that is the reason why when you see fish, for those people that rear fish, I get maybe tilapia fish at home. When the water is no more conducive, you see the fish, they will start coming up like this because they want to enjoy the egg. They will start bringing their mouth. Take note. They will start bringing what? Their mouth in order to what? Inhale gas. Because the level of oxygen in water is now a competitive for them to now compete for. So when it pollutes, they cannot be able to bear it again. And when there is thermal heat pollution, then the water environment is not conducive for the aquatic habitat. Because level of oxygen has what reduced. The only set of aquatic animals that you're going to see in that water is those that their body system can still fight for them. They can make them sustain to a particular level. And those fish that you think they've died, they are no more existing in this particular dead water. You just replace the water and see what will happen. Just try to replace the water, you see what will happen. So the answer yes is level of oxygen reduced. 22. Which of the following is a deliquescent compound? Wow. Before I go to this, someone asked, hygroscopy, deliquescent, efflorescent. Now, which of the following can be made to be as a reducing agent? It's hygroscopic. When you go to your textbook very well, go to the last part of hygroscopy. You will see that hygroscopic compound are also what reducing what agents. Take note of that. Now let's go to number 282, which is which of the following is a deliquescent compound? A deliquescent compound. What are deliquescents? Deliquescents. So if you don't understand deliquescent compound, you might not be able to what? To answer this question. You might not be able to answer this question. So it is good for you to understand what deliquescent is all about. Now, I believe by now we should start trying to at least understand. So let me just give us some hints. I don't know if anybody can hear me. Can you give us what is deliquescent? I don't want to be the only one talking here. What is deliquescent? You can unmute your mic and say something. What is deliquescent? Nobody's talking? Okay. Deliquescent substance. They are substance that tends to absorb what? Moisture from the what? From the atmosphere when you expose them. When you expose them to the atmosphere, they tend to absorb moisture and they will form solution. Unlike hygroscopy, hygroscopy will not form solution. And that is why I love what the textbook put. They will put a sticky. Textbook put what? A sticky something there. So deliquescent substance, when you are dealing with deliquescent substance, is calcium chloride here. The answer is calcium chloride. Another example of deliquescent substance is what? Sodium hydroxide. Magnesium chloride is also part. Copper 2 tetrahydrogenate is also part. Copper 2 tetrahydrogenate. Iron 3 chloride. They are examples of what? Deliquescent substance. Now, if you have not been familiar with this thing, you might not be able to know much. The question I asked some years back is that why can't we measure accurately sodium hydroxide on weighing balance? It is because it's a deliquescent substance, because it absorbs moisture. So when you are trying to weigh, you think you are weighing it, it's absorbing moisture, the weight continues increasing. So you might not be able to measure accurately. Measure accurately. So calcium chloride is the answer here. So another example of deliquescent substance is we have what? Iron 3 chloride, you have magnesium chloride, you have copper 2 tetrahydrogenate, yes. Copper 2 tetrahydrogenate, yes. They are deliquescent substance or compound. So which of the following is this deliquescent compound? We have calcium chloride. Magnesium chloride is also there. Number 23. Number 23. Our time is fast spent. Our time is fast spent. A chemical reaction which the hydration energy is greater than the lattice energy is referred to. The chemical reaction which the hydration energy is greater than the lattice energy is referred to as, the answer here without wasting our time is what? A is not the answer. D is not the answer. It's not reversible. It's not spontaneous. So you might be thinking, you should be thinking between endothermic and exothermic. And the answer here, because the chemical reaction with hydration is greater than the lattice. Lattice is inside. The hydration is outside. Now it's referred to as what? It's exothermic reaction. Because of that, that is why it's going to give out. Because the hydration energy is greater than the lattice energy. That is the reason why it can give out. It loses to the atmosphere or to the environment. I believe you understand that. So, number 25. I plan to stop in number 30 because of our time. Number 20, I think we're number 24 now. Number 24 now. The function of zinc electrode in a galvanic cell is that its function of zinc electrode. Thank God, what is electrode? What is electrode? And where can we find it? We're talking about, we are talking about electrode, we are talking about electrolysis here. Let's go back to electrolysis. We have the word, the cathode and the anode. And the electrode can either be plate or what? rod. So let me not go much into details. Explain electrolysis. You will enjoy it in our app. 24. A undergoes reduction. No. Serve as a positive electrode. No. No. Okay. We can look at that. Let's look at that first. Let's look at that first. B. Production of electron. That is part of it. Use as electron. No. So B and C are likely to be the answer here. A cannot and C can, D cannot. Uses up electron. No. Is electrode? No. So the answer is it serve as positive electrode or production of electron? Zinc electrode. It will produce electron. It will produce. The best answer here should be production of electron. Production of electron. So number 25. Oh, the major factor that influence the rate of reaction here. The major factor that influence the rate of reaction here. Without wasting time here. We have gas here. We have gas here. We have gas. We have solid here. So the answer cannot be catalyst, neither temperature. So the answer should be let's look at it. Is either light or concentration. This gas. Cloning. Oh, this is very simple. When you go to organic chemistry, yes, when you go to organic chemistry, very simple. It's a reaction, is a substitution reaction of alkanes and chlorine. And you know it's going to happen or occur in place of ultraviolet light. So the answer is what? Here's it. Light. Light is the answer. Look at how chemistry is very interesting. Very sweet. But immediately, initially I was thinking, should it be gas, pressure, or should it be temperature? Because but I discovered temperature will not go here. We have gas here, so temperature will not go. Catalyst should not be the best answer here. Catalyst should not be the best answer here. And likewise, concentration should not be the best answer here. We are dealing with gas. Only this one is solid. So here is ultraviolet light. So the answer is light. The condition required for corrosion to take place in the present is the presence of all. When you are talking about corrosion of metals, I do tell my people, my students very well. I said they are gone are those days. In fact, I think the pails, or we call it pail that time, pail or bucket, pail, the iron one, not the stainless one now. When you fetch water, our parents will just tell us, after fetching the water, try to turn it upside down. When you turn it upside down, their initiative and the reason for saying that, we never knew that they were practicing chemistry then, no, sincerely speaking. We thought we that go to school, we are the only brilliant. Not knowing that our brilliant are even the best scientists. Now they told us to. Why? Because they believe, they've tried making findings that when water, there's no how, there's going to be droplets of water. Now, and when there is moisture and air together, it will lead to corrosion. The corrosion will not take place instantly. It's going to take a lot longer time. So when you try to turn it upside down, the water will come down. So when the air comes in, the air will not meet any moisture or water here. So it's going to help. So the answer here, let's look at it. The condition required for the corrosion to take place is A, water and CO2 gas. B, water, carbon, dioxide and oxygen and carbon dioxide. The only answer is what? Let me not waste my time. Is water and oxygen. I've said it. Air and water. That's it. Air and water. Number 27. Oh, this kind of reaction is what? This is exothermic reaction. Reactant here, product here. If the reactant is here and product is here now, then you can say it's an endothermic reaction. So let's look at what is the question saying. In the diagram above, X is the dash. It cannot be activation complex because activation complex will be here. It cannot be activation energy because activation energy will start from here to here. It's going to be between enthalpy and enthalpy change. So the answer here is what? From here to here is enthalpy change. The enthalpy change is the answer. Enthalpy change. 27 is enthalpy change. The diagram below best illustrates the effect of decrease in what? Oh, this rate curve. Rate reaction and the reaction rate. The reaction rate. Here we are going to be looking at the answer here is concentration. The answer here is concentration here. Very, very simple question for us. So when we get to 30, we're going to stop because of our time. We're going to be stopping at number 30. So we have 40 questions in objective. So when you're able to do like with 40 compulsory and you're able to go, so I'll try moving further to at least cover to like 40 questions here to answer it concentration now. Oh, this is very simple. Number 29. But most people will fail this because of the fact that they cannot balance. Now, in chemistry, we have two ways of balancing equation. We have the normal balancing, which is total number of reactants must be equal to the total number of moles of the product, and so on and so forth. That is what we normally teach in SS1. But when you get to SS2 third term or second term or SS3, we do balancing of redox. After doing redox reaction, oxidation and reduction, they will talk about how do we calculate oxidation number. We have done that before here also. And then we go to how to balance redox equation, ionic equation. Now, in this one now, how do we balance it now? How many numbers of moles of manganese? The first thing is, let's look at number of atoms. Number of atoms of manganese is 1 here. 1 here also balance. Oxygen core, we have 4 here. We have 4 here also balance. Iron 5, iron 5, iron 5. Now, hydrogen is 8 here. Hydrogen is what? 8 here. So if you now try looking at it, that it should be 8 here, then we now, if you write 8, then let us look at the number of charge. It can be 8. The only number of charge here is we have 2. Okay, this is 10 and 2, making what? This is 10. Oh, 2, 2, 4, 8. That's 9. And this is 4. Okay, 2, 1, 3. So the answer here is 5 ions here. It will be 5 here when you balance it very well. How do you confirm this? Is just write MnO4 minus to give Mn2 plus. Then you write Fe2 plus to give Fe3 plus. I think something is wrong with this Fe. It should be Fe3 or Fe2. So I think something is wrong, but the answer here should be 5. So the only thing we can be thinking is 5H plus and 8H plus. So when you look at the two, so when you try calculating there very well, you balance number of atoms first, then you balance number of charge. Number 30. Given that M is the mass of a substance deposited during electrolysis and Q is the quantity of electricity consumed, then Faraday's first law can be written as the answer is M. M equals EQ. Don't forget we say IT. Faraday's Q is equal to IT. So it's always the same thing here. M is equal to EQ. It cannot be E divided by Q or E. No. The answer is EQ. EQ. So ladies and gentlemen, this is 1:15. I think we are going to stop here. Don't forget the hint I have given before. The hint I have given before is going to help us in solving a lot of questions here. In solving different questions here, it will help us. So the first one I said, you understand the exam pattern. Try to understand pattern. It is not how well, but the little you're able to do, understand better. Understand the exam pattern. How do they set their question? How do they solve? Set their question. Number 2 is you set a realistic goals. What do you want to achieve within the duration of time? What will you achieve within this period of time? What did I want to achieve within this period of time? Then I look at trying past questions, which we have done now. We've tried looking at past questions. Then we look at how will I be able to manage my time? Most of us are just wasting on our time for unnecessary things. Then I try what? Practice regularly. Continuous reading will help you. Even the Bible says in Joshua chapter 1 verse 8 that the book of law should not depart from you, but you meditate in it day and night. Because he knows that when you practice or you read, you get acquainted with it. As you read, you get familiar with it. As you read, you understand better. As you read, you have more knowledge. So practice regularly and you create a study schedule. Most of us don't have reading timetable. Have reading timetable. Burn candles now because you want to have your result. Burn candles now. Then we go to what? Engage in active learning. Active learning. Don't just learn like that. Active learning. Let it be active. If you are using only 10 minutes, let it be active. You are using 20 minutes, let it be active. Not that you are eating biscuits and you are learning. You are eating biscuits, you are learning. No, no, no. That is not how to do it. Join study group. Form a group. Let's learn together. What have you gained? What have I gained? What can you share with us? What have you share? Can you share? I once said, all the tutors here and the scholars here, we have passed through a lot of things and we have tried discovering something, and that is why we are coming together to bring a solution to the issue, the problem on ground now. When I was in 100 level then, what I normally do is we'll have a particular group of like 5. We'll read. You read biology, you read chemistry, you read physics. We have to read and understand so that when you are coming, you want to come and explain to us. The more you explain, the more you get twisted. So you use educational app. South Africa is the best for you. Youth educational app is going to help you. We have tried solving and breaking. South Africa is there, is there for you. Now you stay healthy, eat very well. Eat. You cannot just be reading and you are not eating and you are not strong. You are having a headache, you are reading. He said it's going to go no. Then you take break, relax. When you relax, you reflect on what you have read. Engage in mindful revision. Your mind revise. A lot of things are going on in your thought and your mind. So then we have your self-assessment. Assess yourself. What have I been able to achieve? Assess yourself. Then you stay informed. Listen to news. There are some things you're going to gain from news. Then you believe in yourself. I want someone to say, I can do it. I will make it. This JAMB will be my first and the last one. And I pray it's going to be so. Thank you for joining us today. Once again, I am Anisha Emmanuel Kende for South Africa. Go to our app. You will learn a lot. Thank you very much.
Thank you very much for that amazing class, Mr. Anish Emmanuel. So our students and every other person who join us, we appreciate your time and we are very glad to see you again this week. And next week, we'll be having another section with another instructor on another topic, subject. So invite your friends in school, colleagues to come and join us. To come and join us in this ongoing past question breakdown. So the next thing now is to unveil the face of the week for South Africa. Now, I hope we still have some of our students on with us.
Yeah.
So I'll be sharing my screen right away. Yeah, this is it. So the South Africa face of the week for this week is Oyenwenu Ozioma Peace. So congratulations. We appreciate. Please let's put our hands together for Oyenwenu Ozioma. I hope I'm able to to pronounce that word. Let's clap virtually for him. So we appreciate your engagement. We appreciate your participation on the South Africa community, and congratulations for being the face of South Africa for this week up until next week. And please reach out to the admin or the South Africa community to receive your award. So with that, we'll be closing the curtain here today, and the next session for the learning is coming up next week. The same time, 12 p.m. and on Google Meet as well as YouTube. Please invite your friends, invite your colleagues to join us in this section. Thank you everyone for joining us, and have a nice weekend. Bye.
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 Bye.